Bryan, what was the inspiration for this building here? Was it your idea?
Well, we've seen Cordwood buildings before, and basically the inspiration was that they can be made out of lightweight firewood or timber, like Pinus radiata, and it's a very sustainable way of using pine. It doesn't need to be treated for preservation purposes, because the what's the insect that gets into them? The borer goes into the side grain, and this is very alkaline, the plaster. It's made of hydrated lime and pumice, and so it's pretty much, you know, insects hate it.
If someone wants to build a structure like this, what will they need?
Oh, they need access to a stand of pine trees or some other lightweight timber.
Yep.
And a chainsaw. We use pumice with our hydrated lime, which you buy from any building suppliers.
Pumice is?
Pumice is a volcanic, it's all over the central North Island. It goes 50 metres deep in lots of areas, and it's everywhere in the central North Island. It goes over to Whakatane, to Whanganui, so...
Is it soil?
No, it's... you just dig it up.
So this is pumice here.
Yeah.
And
it'll float on water.
It's very light.
It used to be used in New Zealand in the early days of refrigeration for chillers and freezers as the main insulator.
And you can just grind it up.
Yeah. Well, you don't grind it up. You just dig it up in its ground up form.
Okay.
So, and what we do is we just sieve it so that we keep the fines and turn it into the plaster with the lime. But equally, if you were somewhere else in New Zealand, you'd use sand.
Okay, so you can use sand and lime.
But the advantage of the pumice is that it's so lightweight, full of air, so it's a better insulator.
Okay.
So what you're wanting is a timber that actually isn't thermal mass. It's not heavy, dense wood, because that acts like lumps of rock. What you want is something that allows the moisture to transport out through the building, out of the building, very easily. And because it's such a breathable structure, and we've got the windows over here that face to the north, they heat up the interior, and it basically acts as a sort of a moisture pump pushing it out through the walls.
So this is good maybe for moist areas.
Oh yeah,
so
yeah. It's
it
used in saunas and things like that.
Saunas?
Yeah.
Is it breathable because of the way the wood's lying?
Yes,
that
the end grain easily admits it and takes it straight out the other side, and there's air taking away the moisture on the other side.
Interesting.
And this has got two layers. So here we've got a layer of plaster that's 2 inches thick, and on the other side's another layer of plaster, and in the middle is sawdust that's mixed with hydrated lime. So there's a thermal break, so it's not plaster right through, and so it's very it's just an incredibly insulated building. I would do it though. This is actually only 200 mils thick, this wall, which is not, in my view, satisfactory. It needs to be about 300 mils thick, be much stronger and much more insulation quality, just more robust. This is actually bags with pumice and cement, so it's a pumice cement foundation that raises it up above the surrounding area. There's a membrane under it, and so the moisture can't rise up through here.
Plastic?
Yes, just
big
a plastic floor.
So it's a big dip?
Yeah.
Plastic?
Yeah, and we've actually just put metal in here, and we'll finish it off with an earth floor.
Earth floor made of?
Well, it'll probably be clay and pumice or clay and sand, and then it'll be waxed and oiled. Oh. So it'll be a nice solid floor and good feel, and yeah.
What will you do with it?
Warm floor. This room?
Yeah.
It's sort of intended originally as an office sort of place, and it might be that, but it might also be a library too. So we just haven't really I mean, the thing about building any building is you need to build it in such a way that can be used for many purposes, and so. But it's a nice building to have here.
Feels good. I like it.
Yeah.
It's dry and warm.
Originally we were going to have a living earth roof, but our tutor for it was a North American and not used to earthquakes and things, and so if I did it again, I'd put these posts so that there was an extra one in, and I'd put bracing structures in it and things like that. So it's just not up to carrying heavy loads, in my view.
Right.
We can actually rectify that on this building by putting external bracing on it quite easily, and it will be attractive. No one would know the difference. And then if it was done properly, then it would carry a heavy roof, and we'd have tussocks and things growing up there. It'd be very nice, yeah.
So what is your intention behind building all these structures?
Well basically, when you're building in New Zealand, you can build without a consent under 10 square metres. Anyone can do that, and we want to show people that they don't have to be mortgaged for a lifetime to have a dwelling, and anyone with a chainsaw can cut Pinus radiata. It grows all over the country. The foundation, you can find material wherever you are that's suitable for foundations, and it's something that people can do at minimal costs with their own labour, and they don't have to go into debt. And I think debt-free housing is the only way to go.
I love that about you.
Yeah. This was done in a workshop, and you can see there's a consistent pattern up to about here. And so here and around the back wall was done over pretty much a weekend with people learning, and there were probably about 8 people, if I remember rightly, working on it. So that gives you an idea of what progress you can make with a bunch of people who are excited about the process and getting stuck in. So jobs can take as long as you like, or they can be very efficient and yeah, if they're well managed.